Good day. For those of you who don't know me, my name is Douglas Harder, and in this topic, we are going to discuss inner product vector spaces. So in this topic, we will be introducing the next chapter on the inner product and vector spaces with such an inner product. We will be defining the inner product for finite dimensional vectors, including r to the n and c to the n. We will describe the norm induced by this inner product. We will consider inner products on other vector spaces, including discrete signals and continuous signals. We will define the concept of orthogonality of vectors. We will then consider orthogonality in other vector spaces. We will then revisit the Pythagorean theorem from secondary school. We will be describing projections and best approximations of one vector by another. We will be describing the Cauchy-Bruniakowski-Schwarz inequality. We will be defining the angle between vectors, and we will be describing the Gram-Schmidt algorithm. Now, the inner product, denoted here with two angled brackets with the two vectors, is a measure of the angle between two vectors. So we will be using this to describe the relationship between these two vectors. Also, we will be using this to say, for example, find the best approximation of one vector by a scalar multiple of another. We will also see that the angle between two vectors can be described by the following relationship. Now, in secondary school, you may have called an operation like this called the dot product. Like we now use the 2 norm instead of the Euclidean norm, we will be using the phrase inner product and not the dot product. Now, we are going to also be using the angle bracket notation specifically because this is the notation you will be using with wave functions in your second year course on quantum mechanics. And I want you to become familiar with this notation. Many of you are already familiar with the dot notation for the inner product. And this is the notation you will see again in calculus and in your physics courses. Please note, however, that even though it is a dot, it is not the multiplication of two vectors. The dot product, or the inner product, is going to result in a scalar value, not a vector value. Now, following this chapter, you will be able to calculate the inner product between two vectors. You will be able to describe the relationship between the inner product and the 2 norm. You will be able to use orthogonality and be able to apply the Pythagorean theorem as appropriate. You will be able to find the best approximation of one vector by another using projections. You will be able to describe the angle between two vectors and find that angle, and you will be able to apply the Gram-Schmidt algorithm. So, following this topic, you are now aware of what the next few sections will cover. You are understanding that we are measuring the angle between vectors, and you know that we will be using the term inner product, not dot product, and we will be using the angled bracket notation and not the dot notation. Here's the references, the acknowledgements, colophon, and a disclaimer. Cheers!